All right, we are live everywhere. Nice. Excellent. Cool. Hello, everyone. I hope you are watching this at some point in the future. I'm Grex, and yeah, we are continuing these sessions on doing some coding challenges in this site called CodeSignal. Why? Because I want to get better at doing some problem solving, and this is always useful. And I think that by now it's pretty much a standard in any big tech company for them to do some live coding, right? Whenever you are applying for a software development position. I'm a software developer with many years of experience, but I still need, and everybody probably needs some practice on this, right? We were following this journey in here, and right now we are in this problem. And on the left we have the problem statement, and on the right we have the part where we should implement the solution. I don't remember if the last one we implemented it in Java or in Golang. Doesn't matter. Probably let's do it. Let's start with Golang, then we switch to JavaScript, and then we switch to Java. All right. Nice. Let's jump into it. Cool. So yeah, problem statement on the left, right? So given integers a and b, determine whether the following pseudocode results in an infinite loop. While a is not equal to b, do increase a by 1 and decrease b by 1. Okay. So what? There should be probably the difference between these should be that A is A should be smaller than B always. Same, right? So that's the first condition, and the second one is that there is a the difference between A and B. It's like a multiple of 2, right? Why? Because if you're increasing A and then you're decreasing B at some point, if the difference between these two, I mean, it's not if the difference between these two is of some, if it's not even, then it will continue this loop forever, right? That's what we're seeing here. So assume that the program is executed over the machine that can store arbitrarily long numbers and execute forever. All right, let's see. So A is 20 and B is 20, right? Okay. Pseudocode will never stop. Okay, so okay, so then let's see, right? Return the A is bigger than B, right? Or A, okay, so B minus A mod 2 is different than 0, right? Or equals 1. Right, because this should work. Okay. Okay, so 1% solved in Golang. Yeah, I think this is too straightforward, right? Everyone should have, yeah, similar conditions, right? Similar. Oh, this is interesting. It looks almost the same as in Go and in C++. Right, so there's not much to check, right? So similar logic. Cool. Let's move on to the second question of today. Now we will do it in JavaScript. Yeah, probably we can do a random selection next time from all of these. And I've never heard of D. What is this? Okay. Let's not get distracted. Cool, now we are doing it in JavaScript. Now the statement on the left, right? So consider an arithmetic expression of the form a hashtag or h pound v equals c. Check whether it is possible to replace the hashtag with one of the four signs or to obtain a correct expression. Okay, so I guess it's also somewhat straightforward, right? So you try all of these combinations in the return statement, right? So in this case, so a plus b equals sorry, c or same, right? There's no need or this one or this one, right? Yeah, I mean, there's no much to it, right? So because the problem is pretty much it's pretty limited or pretty simple, so you might as well try it, right? So you can do it, of course, with a loop or something else, but I think it's straightforward and you don't need to break your head going overboard with this. All right, I'm pretty sure that most of these will be the same. Yeah, you see, it's the same. Yeah, same, just different way to put it. Creating a list or creating this tuple, I think it's called. I don't know. Yeah, so this is not probably the best because you are evaluating the expression. Yep. Okay. We did pretty good. Now let's go to the third one. What should we do it? Where should we do it? All right. So do we do it in Kotlin? Yeah, let's do it in Kotlin. Why not? Okay. So in tennis, the winner of a set is based on how many games each player wins. The first player to win 6 games is declared the winner unless their opponent had already won 5 games. In which case, the set continues until one of the players has won 5 games. So, given 2 integers, score 1, score 2, your task is to determine if it is possible for a tennis set to be finished with a final score of score 1 or score 2. What? I don't get it. Since player 1 hasn't reached 5 wins, the set ends once player 2 has won 6 games. Okay. Could it be false since both players won at least 4, 5? The set would have ended one of them won the 7 one. Is it okay if it's possible for the institutions with a final score? I guess you only need to check if one of these is a 5. Right, so in this case, what is done, score 1 equals 5, or score 2 equals 5. Up, typo. Yeah, probably Kotlin takes some time to compile. Yep, probably we won't do it in Kotlin. Okay, so then I don't get it. So console output. So then it's probably bigger or equal than this. No, okay, so different than 5, right? Then I don't get it. So 7, 7, then well, let me just reread it again. Okay, so in tennis, the winner based on how many games each player wins, right? So the first player to win 6 games, the winner, unless the opponent had already won 5 games, in which case it continues into one of the players. Okay, okay. If it's possible for them to finish with a final score. Okay. Okay, now I think I get it. Right, so if you have no wait, but then this should have been ended with the score. So this ends because this guy has 6, this one has 3, right? Because it reaches this one. Hadn't reached 5 wins, the set ends when the player, okay. Well, player won at least 5 games, set would have ended would okay, would have ended but won't end. Okay, so this is not possible. Okay. So it's not valid scores, right? So this set will continue until one of these players wins their 7th game. Okay. So let's score 1 is smaller than score 2. Let's just call it return solution score 2 score 1, just for us to have it, to always have the smallest in score 1, right? Okay, so now if score 1 equals score 2, so they are the same, what do we do, right? So given to first player to win 6, declare the winner. So 7 and 7 return value, okay. Okay, so this one is always false, right? Why? Because if it's 5 and 5, then it cannot end. If it's 6 and 6, it cannot end. If it's 7 and 7, it cannot be possible, right? Okay. And if it's 1 and 1, of course, it's also not possible. Right. So now we have, okay, so score 2. Oh, yeah. Let's just move this one up. Doesn't matter. Okay, now if score 2 okay, so if score 1 is smaller than 5 and score 2 is bigger than 5, this is true, right? So it's the normal case. Let's just put it here, right? But some 1 1. Okay, so return someone 1 or but someone wait and okay, this one is 6. This is 6, right? If it's 7, yeah, I guess this will work, right? So it's either this case or no case. Okay, so let's see. Oh yeah, sorry. Okay, so here score 1, doesn't matter, 5 and 7. Okay, yeah. Okay. Then val someone 1 with 7. Then score 1 equals 5 and score 2 equals 7 or are someone 1 and 7. Yeah, everything else above 7. Okay, so then is, I guess I need to play more tennis. Hello, Jonathan. Yes, I'm planning to do it after this. You wanna do some pair programming? It's you hate it because you don't do it enough, you know? Let's do this one. Right, let's read the. Yeah, maybe we should do it in Lua, you know? I think it's available here. Yeah, you know? All right, Jonathan, let's do it. Feel free to drop any hints on the chat, you know? Cool, so let's read it, right? Once Mary heard a famous song and a line from it stuck in her head. That line was, "Will you still love me when I'm no longer young and beautiful?" Ah, wait, that's a song, right? Yeah, Lana, right, okay. Mary believes that a person is loved if and only if she is both young and beautiful, but it is quite a depressing thought, so she wants to put her belief to the test. Knowing whether, man, this problem is dark AF. Knowing whether a person is young, beautiful, and loved, find out if they contradict Mary's belief. A person contradicts Mary's belief if one of the following statements is true. They are. Yeah, let's see. Let's see. A person contradicts Mary's belief if one of the following statement is true. So they are young and beautiful, but not love, but not young or not beautiful. Okay, so just a return statement, right? So if it contradicts Mary's belief, in this case, and I haven't done Rust since what? Since the CLI tool. Wow. Okay, so if return if love and uh, is it young and beautiful or beautiful young but not love. Okay. Does it work? Okay, so what there but not love? Mm-hmm. Hello, but not John. Okay, so this is an OR, right? What do you mean the opposite? Like, yeah. Just this one, right? So this was the problem. I'm not sure whether we're supposed to return true if it validates. No, it returns true, yeah, if it contradicts the thing, right? And this one, love, not young, not beautiful. All right. This is probably the most idiomatic Rust that you could find anywhere in the world, you know? Okay, love. Yeah. Yeah, I guess it's this case is repetitive, right? Maybe we just need one statement. But come on, let's move on. Right. So this other statement, Metro card. You just bought a public transit card that allows you to ride the metro for a certain number of days. Here is how it works. Upon first receiving the card, the system allocates you a 31-day pass, which equals the number of days in January. Second time you pay the card, blah blah blah. The number is blah blah blah. The third, you get, you extend the pass, you get, okay, whatever. So you just run out of days on the card. Unfortunately, you've forgotten how many times the pass has been extended so far. However, you do remember the number of days you were able to ride the metro during this most recent month. Figure out the number of days by which your pass will now be extended. Let me just share you this. Okay, so figure out the number of days by which your pass will now be extended and return all the options as an array sorted in increasing order. First of all, what? There are 30 days in April. Oh wait, let's switch it up. We did Golang, JavaScript, Kotlin, Rust. What should we do? Jonathan, what do you say? Lua, TypeScript, or something? Rust? Man, we already did Rust. Maybe Ruby, you know? Okay, let's do Ruby. My favorite out of all languages, Ruby. Cool. Now, yeah. All right. So for last number of days, the output should be 31, but the number, I don't fully get it. Right? So unfortunately, you've forgotten how many times your pass has been extended so far. However, you do remember the number of days you were able to ride the metro during this most recent month. Here's the number of days by which your pass will now be extended and return all as an array sorted in increasing order. So there are 30 days, the explanation. right? So there are 3 days in April, June, September, yeah. So the next months you consider May, July. Okay, I'll then have it, which means that you will definitely get a 30 days back the next time you extend the card. Okay. Okay, possible of days for which you will extend your pass can only be equal to, but this is super easy, you know, like, so if, yeah, isn't it like, if last number of days equals 30 and then return, yeah, right? So if it is, or last day, yeah, equals 28, and then for anything else we return 28, 30, and 31, right? Yes, because in this case we know that after the wait, this is not the after the months with 30 and 28 days, there's always a 31 day month, right? And for the other one, for every 31 day month, yeah, this is a possible, right? Because it could be that the 31 day month is January, then the next day, the next month is 28, and then if it's any other regular 31 day month, it's also 30, and then if it's December, then January, right? Bam, bam. Yep, exactly. Again, super idiomatic Ruby. Now let's move on to the other one here, to the next problem. Let's see it. What do we do? Jonathan, which one? Ah, wait, this is limited. Now we only have JavaScript, Ruby, Scala, Python, Go, Java. Let's see, what's the problem? Maybe we can do it. How do we solve Java? Yeah, maybe we can do it in Python. It's been also pretty long time since I've done it. I've done something in Python. Let's see. Implement the missing code. Denote by ellipses. You may not modify the pre-existing code, meaning that we should do it in one single line, right? In order to stop the math coder evil genius, you need to decipher the encrypted message he sent to his minions. The message contains several numbers that, when typed into a supercomputer, will launch a missile into the sky, blocking out the sun and making all the people on Earth grumpy and sad. You figure out that some numbers have a modified single digit in their binary representation, more specifically in the given number, and the kth bit from the right was initially set to 0, but its current value might be different. It's now up to you to write a function that will change the Kate bit of n back to 0. Okay, looks straightforward, but I don't know how to do shift manipulation in Python. Let's see. Python 3. Shift bit int. Do you know, Jonathan? No idea. Yeah. Okay, so shifted. Yeah. Yeah, me neither. Okay, so I guess it is. How do we do it? So we do an XOR, right? So we do an. Is it also XOR in this? Let me see. We need to do the XOR. Yeah. Of shifted K, right? And I think this should work. Okay, no, what happened? K, isn't it? Maybe K minus 1? Nope. So we need to make sure to yeah, so this one will shift the one to the required position, right? And we need to make it 0. And for that, wasn't it XOR? You know, like, so if it's 1, it returns. If it's 1 and 1, it's wait. Yeah, right. So if you have 1 and 1, it returns 0. Yeah, if it's 0, 0, it returns 1. Okay. No, then this is not what we want, right? Because we want for this, for the one in that position to always be 0. So for that, we need to, how do we do? Complement bitwise operator Python. How do we make it? Okay, yeah, with this one, right? So we'll convert all ones, yeah. Then this should make it so, and then this should be it. Right. Because this shift the one into the position that we want. And then this one transform all the zeros to 1. And with the AND, we make sure that the 0 that we put remains 0 in end, right? Perfect. Let's see. Yep. Look, they copied our solution, you know? Same, these people. All right. Jonathan. Um, Now let's do another one. Do you wanna jump on a call and do some pair programming, or do you wanna stick to the chat? All right. I'll I'll continue with this. Cool. So you are given an array of up to four non. Come on, this is fun, Jonathan. It's nothing related to work, you know? It's like flight simulator, but for with code. All right. So you are given an array of up to four non-negative integers. Each. I was actually thinking of doing a game, but I need to mm, get started, I guess. What is game engines uh, for for beginners, for advanced programmers, right? Which ones of these, Jonathan, do you recommend? Godot, Unity, or Unreal? Depends on the game, probably. Yeah, let's do it. Maybe let's just finish this problem and then we switch to Godot. What's the language that is uh, that you use here in Godot? Is it Python or Golang or their own thing? So influenced by C, C++, and Python, but it's their own thing, right? Interesting. What? C sharp? Who would use C sharp? Come on. Wait, do we have that language here, GD? Wait, let me make it small because some of the languages are hidden. Give me one sec. No, we don't have it available. Okay. Let's jump back into the what is this? Into the code. And we can start maybe with game development tomorrow. I'll prepare something today and tomorrow's stream would be related to game development. Okay, so you are given an array of oh wait, let me switch it. What do we do? Do we do Golang, JavaScript, TypeScript, Dart, Lua, Kotlin? No, I don't want to wait for the thing to compile. Go. Yeah, all right. Cool. Then you are given an array of up to 4 non-negative integers, each less than 256. Your task is to pack these integers into one number m in the following way. The first element of the array occupies the first 8 bits of m. The second element occupies the next 8 bits, so and so on. Return the obtained integer m. No, the phrase first bits of m refers to the least significant bits of m, meaning from right to left, right? For furthermore clarification, see the following example. The output should be, okay. So in binary, what? Okay, so it has, okay, so your task is to put this integers into one number following the first element of occupy the first 8 bits. Okay. Okay, so we need to, revert the array or traverse reversely from end to beginning. And then just append to append leads to integer, right? Of course, 8 by 8. And then return results. Let's put it here, result 0. How do traverse Golang array reverse order? Let's see, reverse, okay, no. Okay, the classic, there's no shortcut. Is there a shortcut? Nope. Okay, no shortcuts, and let's do it, right? Minus len a minus 1, then here then 0, and then plus wait, there's no plus plus in Golang. And then so result should be what is it, and or is or, right, with the wait, with a on I, and then this is it, right? So okay, yeah, this is how we do it. Okay, we shifted first 8, and I think this will work. No, what happened? Error output. Index out of range. What? Of course. Perfect. It works. So yeah, so we are shifting whatever it currently is in result, and then we are appending just the inter, right, to it. And because the input here is guaranteed to always be valid, we don't need to validate. It's straightforward. Okay. Perfect. Let's see what other people did. So they add all of these, moving it, wait, shifting this to the left. Yeah, I guess this also worked. I didn't want to do the shift first because I thought that maybe, like the inter would be too big, but that will also violate the restrictions, right, or the constraints from the problem. So I think this works. Okay, so reduce. Then the value, the index, right? And then what? No, sorry, this is the index. And these are the right, yeah, and the current value. Yeah, okay. So they did the same. In from bytes. Okay, what language is this? Python 3? Okay, nice. I don't know what is this. Let's check it out. In from bytes. What? Let's byte order. Byte. Look at this. It has exactly, yeah, it does, this function does exactly what you need or what the problem stated, right? Even with the parameters here. And even if the integers in there are signed or unsigned. Pretty cool, pretty cool. I guess that's why we all love Python, right? Well, Jonathan, it has been a pleasure as always. Thank you so much for your views, and I'll see you tomorrow or later. Bye bye.